Welcome to 15-Minute Discourse. Today we're going to be taking a deep dive into asteroid colonization.
Sounds exciting.
Yeah, you sent over a really fascinating mix of sources. We've got academic papers, Wikipedia articles, even some sci-fi in there.
Right?
And it seems like you want to kind of get to the bottom of how, why, and maybe even when humans could set up shop in the asteroid belt.
It's a fascinating topic, and there's a lot to unpack.
Yeah, for sure.
It's a question that's captured the imagination for decades.
Right.
And for good reason.
Yeah.
The possibilities are as vast as space itself.
Absolutely. A few of these sources kind of jump right into the deep end, but existential threats to humanity.
Yeah, I noticed that too.
Climate change, pandemics, even the threat of nuclear war.
Mm-hmm.
Do you think these are really pushing us towards kind of this space exodus?
Well, you know what's really fascinating is that many of these sources seem to agree that establishing off-world colonies isn't just about exploration anymore. It's about safeguarding humanity's future.
Like a backup plan?
Exactly like a backup plan. And one paper even uses the term window of peril,
Oh, wow.
arguing that we're in a particularly vulnerable period that started with the development of nuclear weapons,
Right.
and suggests that this window won't close until we have self-sustaining colonies beyond Earth.
That's a pretty sobering thought.
Yeah, it is.
It's like we're in a race against time to spread out and diversify our species' presence in the cosmos.
Exactly. And then you have this,
Yeah.
great filter hypothesis,
Right.
which suggests there might be some kind of cosmic barrier
Interesting.
that wipes out intelligent life before it can truly become a spacefaring civilization.
So we got to get out there before that filter gets us.
Yeah.
So it's not just about escaping a potentially damaged Earth, but also about proving that we can make it as a multiplanetary species.
That's right.
It's like a test of our resilience and adaptability on a cosmic scale.
Precisely. And to pass that test, we'll need to leverage our technological prowess,
Right.
which brings us to another fascinating theme woven through your sources:
Boom.
the role of technology in enabling asteroid colonization.
Absolutely. One of the sources dives into the connection between the grosser computing power, complexity of the human brain.
Interesting.
It uses this analogy of transistors on a chip compared to the intricate network of neurons and synapses.
That's a really interesting comparison.
Yeah, it is.
What's intriguing about that analogy is the suggestion that our ability to venture further into space is directly tied to advancements in computing power.
Okay.
We need incredibly sophisticated systems to design, build, and operate spacecraft
Right.
capable of long-duration missions to the asteroid belt, not to mention the infrastructure required to establish a colony once we get there.
Right. We can't just set up a tent on an asteroid.
Not quite.
So we're essentially waiting for our technology to level up before we can realistically consider building settlements on asteroids.
That's one way to look at it.
Okay.
And some experts are even projecting potential launch dates for crewed missions
Interesting.
based on the expected growth of computing power.
So what are we talking?
Well, for example, one paper suggests that while a human landing on Mars could happen within this century,
Okay.
a full-fledged asteroid colony might not be feasible until the 22nd century.
Wow, so we got some time.
We have some time.
Mars does seem to be a recurring theme in a lot of these sources.
Yeah, for sure.
Do you think it makes sense to focus on establishing a Martian colony first, or venturing further out into the asteroid belt?
I think a lot of the sources seem to lean in that direction,
Okay.
suggesting that Mars is kind of like a crucial stepping stone.
Right.
One paper even posits that it's the most economically viable location
Oh, wow.
for colonization in the solar system,
Interesting.
thanks to its relative proximity to Earth and its potential resources.
Okay, so Mars is like a test run for the more ambitious goal of colonizing the asteroid belt.
That's a good way to think about it.
And your sources even delve into some of the practical challenges of getting to Mars,
Right.
which are obviously relevant to asteroid colonization as well.
Exactly.
For instance, one BBC article explores the possibility of using hibernation for those long-duration space flights.
It's a fascinating idea.
Yeah, like a cosmic power nap. But wouldn't that be incredibly risky?
Well, the article acknowledges that there are risks involved. It also points out the potential benefit. Hibernation could help mitigate the harmful effects of radiation and microgravity during extended space travel.
Right.
And it could also significantly reduce mission costs by minimizing the amount of food, water, and oxygen required.
So it's a trade-off between potential risks and potential rewards,
Absolutely.
which seems to be a theme that runs through this whole idea of asteroid colonization.
Absolutely, and as we delve deeper into your sources, we'll encounter many more of these trade-offs, from the challenges of resource extraction to the ethical implications of establishing a human presence in a new celestial environment.
Right, right.
Speaking of which,
Yeah.
you even have a source that explores the potential cultural implications of asteroid colonization.
Right. One of them describes a fictional group called the Belters,
Oh, yeah.
people who've adapted to living in the asteroid belt and have developed their own unique culture and language.
It's a fascinating thought experiment. How might human societies evolve as we spread out into space?
Right.
Could we see the emergence of distinct groups shaped by their unique environments and the challenges they face, just like the Belters in that story?
It's like, will low-gravity sports become a thing? Will asteroid slang seep into our everyday vocabulary? Who knows what kind of crazy cultural innovations might emerge from the asteroid belt.
Exactly.
But before we get too caught up in the cultural implications,
Yeah.
let's zoom back in on the practical challenges of building a home on an asteroid. I mean, we're talking about giant chunks of rock hurtling through space.
That's right.
Not exactly the most hospitable environment.
Definitely not a tropical paradise.
Right.
You're absolutely right.
Yeah.
And the sources acknowledge that building habitable environments on asteroids will require us to address some fundamental needs like shelter, energy, food,
Right.
and even protection from the hazards of space, such as radiation and micrometeoroids.
So it's not just about getting there, it's about surviving and thriving
Exactly.
once we do.
Right.
And one source that really captured my attention
Okay.
talks about this futuristic concept called a guided self-replicating factory, or GSFR for short.
Ah, yes, that paper caught my eye as well.
Yeah,
It's a bold idea,
it is.
essentially proposing a factory that could build copies of itself,
Oh.
using resources found on an asteroid.
But how would that even work? What kind of resources are we talking about?
Well, that's where it gets really interesting.
Okay.
Asteroids are essentially treasure troves of valuable resources,
Okay.
including metals, water ice, and even organic compounds.
Wow.
The GSFR concept proposes using these materials to create everything from habitats and power systems to spaceships and even more factories.
So we could potentially bootstrap an entire space-based civilization
Yeah.
using the materials already out there in the asteroid belt. Talk about resourcefulness.
Exactly, and it's not just about construction materials.
Right.
Your sources also delve into some innovative energy solutions for powering asteroid colonies,
Like what?
including things like thermionic converters
Mm-hmm.
and potassium vapor turbines.
Hold on. Potassium vapor turbines. I have to admit, that one went over my head.
Yeah, it might sound a bit complex,
Yeah.
but the principle is fairly straightforward.
Okay.
These turbines use the extreme temperature differences found in space to generate power. Think of it like a steam engine, but instead of water. They use potassium, which has a much lower boiling point.
Okay.
The heat from the sun is used to vaporize the potassium, which then drives the turbine.
That makes more sense.
Right.
So it's like harnessing the power of the sun indirectly. Pretty ingenious, actually.
It is,
Yeah.
and it highlights the kind of outside-the-box thinking.
Mm-hmm.
We'll need to make asteroid colonization a reality.
Right.
It's not just about adapting existing technologies. It's about inventing entirely new ones
Yeah.
that are specifically tailored for the unique conditions of space.
Speaking of unique conditions, one thing that kind of struck me as a major challenge dealing with radiation and microgravity.
For sure.
Our bodies are simply not designed for long-term exposure to those kinds of environments.
You're right. Those are significant hurdles.
Yeah.
But your sources point to some potential solutions that are being explored.
All right.
For radiation, there are ideas like using silicon crystals to deflect harmful particles or creating artificial magnetic fields to protect habitats.
Right. Like a force field.
Kind of like a force field.
Yeah.
And for microgravity, one of the most promising approaches is designing spinning habitats
Okay.
that use centrifugal force to simulate gravity.
Spinning habitats.
Uh-huh.
Like giant space wheels.
Yeah.
That sounds straight out of a sci-fi movie.
It does.
But it would be amazing if we could actually create artificial gravity.
It would be a game changer.
Yeah, it would solve so many health problems
Absolutely.
associated with long-term space travel.
It certainly would, and it would make life on an asteroid much more comfortable
Right.
and sustainable.
Okay, so we've got self-replicating factories, space turbines, and spinning habitats.
Yeah.
What about the most basic human need, food?
That's right.
Can we actually grow crops on a giant space rock?
Well, that might sound like science fiction,
Yeah.
but it's a challenge that scientists and engineers are actively tackling.
Okay.
Your sources delve into the potential of hydroponics, which is essentially growing plants without soil,
Right.
using nutrient-rich water solutions.
So no more digging in the dirt. It sounds futuristic, but also kind of sterile and, well, not very appetizing.
Well, hydroponics has actually been used here on Earth for
Right.
quite some time.
Okay.
And it's proven to be an efficient and sustainable way to grow a variety of crops.
Mm-hmm.
And in space, it offers several advantages.
Like what?
Like not needing large amounts of soil, which would be difficult and costly to transport.
Right, that makes sense. But what about protein? Are we going to be living on space algae and protein bars forever?
Not necessarily. Some of your sources actually discuss the possibility of raising livestock in space.
Wait, cows in space.
Not quite moonots,
Yeah.
but the idea is to create closed-loop agricultural systems
Okay.
within asteroid colonies, and that might include raising certain types of livestock for milk and other dairy products.
Okay, I'm trying to picture this.
Yeah.
Space cows, hydroponic lettuce, maybe even some zero-gravity wine.
Yeah, why not?
It's like a cosmic farm-to-table experience.
You're getting the idea.
The goal is to create self-sufficient agricultural hubs within asteroid colonies so that we're not entirely dependent on supplies from Earth,
That's right.
which makes a lot of sense, especially if we're talking about establishing permanent settlements on asteroids.
Yeah,
We can't rely on a cosmic delivery service forever.
exactly. And this brings us to another key theme that runs through your sources,
Yeah.
the economic potential of asteroid colonization.
Right,
It's not just about survival, it's also about opportunity.
right. I remember a few of the sources mentioned asteroid mining.
Yeah.
They're packed with valuable resources, right?
That's right.
Metals, water ice, even organic compounds. It's like a cosmic Home Depot out there.
Yeah, a veritable treasure trove.
But how do we actually get all that stuff off a low-gravity asteroid?
That's one of the key challenges.
Yeah.
And the sources highlight the need for specialized mining equipment designed to operate in those unique conditions.
Okay.
For example, one paper describes mining ships equipped with tethers and grappling systems to secure themselves to asteroids during extraction.
It's amazing to think that we're already designing tools for jobs that haven't even been invented yet.
I know, it's really remarkable.
It speaks to the forward-thinking nature of this whole endeavor.
It certainly does, and it's not just about extracting the resources.
Right.
It's also about processing them in a way that's efficient and sustainable.
Okay.
Some sources even propose setting up refining facilities on asteroids or in nearby orbital stations.
So instead of hauling raw materials all the way back to Earth,
Yeah,
we'd be doing some of the initial processing right there in space.
exactly. It would reduce transportation costs and allow us to create a more self-sufficient space-based economy.
Okay, and speaking of economics,
Yeah,
your sources suggest that asteroid mining could be a lucrative endeavor,
absolutely.
potentially generating trillions of dollars in revenue.
Trillions with a T.
Wow, trillions.
Yeah.
Now we're talking. What exactly makes asteroid mining so potentially profitable?
Well,
Is it just the raw materials?
that's certainly a big part of it. Asteroids contain vast quantities of metals like iron, nickel, and platinum, which are essential for construction manufacturing and various high-tech industries.
Okay.
But it goes beyond just the common metals.
Okay. What else is out there? We're talking space diamonds or something?
Not quite diamonds, but some asteroids are rich in what are called rare earth elements.
Okay.
These elements are crucial for advanced technologies like electronics, batteries, and renewable energy systems, and they are becoming increasingly scarce on Earth.
So asteroid mining could help address some of the resource constraints here on Earth.
Yeah.
It's almost like a cosmic recycling program, reclaiming valuable materials that were scattered throughout the solar system billions of years ago.
That's a great analogy.
And it highlights the potential of asteroid mining to not only create economic opportunities,
Right.
but also to contribute to a more sustainable future for humanity.
Absolutely, is a win-win.
So it's not just about profit, it's about diversifying our resource base and ensuring that we have access to the materials we need for future generations.
Yeah, thinking long-term.
It's like investing in a cosmic savings account for humanity.
Exactly. And it's not just about the economic and sustainability aspects.
Okay.
Your sources also highlight the scientific and technological advancements
Okay.
that could emerge from asteroid colonization.
Okay, give me some examples. What kind of scientific discoveries could we make by setting up shop on an asteroid?
Well, for one thing, asteroids are essentially time capsules
Interesting.
from the early solar system.
Okay.
They contain pristine samples of material that have remained largely unchanged for billions of years.
Wow.
Studying these samples could provide invaluable insights
Right.
into the formation of our solar system and the origins of life itself.
Wow, that's incredible.
It is, isn't it?
It's like having a window into the past,
Yeah,
a chance to unravel some of the biggest mysteries of the universe.
absolutely. And by establishing a presence on asteroids,
Yeah.
we would also have a unique vantage point for astronomical observations. Okay. Imagine telescopes positioned on asteroids, far from the light pollution of Earth.
Right.
They could provide unparalleled views of distant stars, galaxies, and other celestial phenomena.
It's like having front row seats to the greatest show in the universe.
It really is.
But telescopes aside, wouldn't the harsh conditions of space make it difficult to conduct scientific research on asteroids?
There would certainly be challenges.
Yeah.
But your sources point to some potential solutions.
Like what?
For example, one paper suggests building underground laboratories or habitats within asteroids,
Okay.
where scientists would be protected from radiation and temperature extremes.
Ah, so like a subterranean space station? That's a pretty cool concept.
Yeah,
It's almost like we're going back to our cave-dwelling roots, but this time on a cosmic scale.
that's a really interesting way to put it.
Yeah.
It underscores the adaptability and ingenuity that will be required to make asteroid colonization a success. We'll need to think creatively and leverage all the tools at our disposal, from advanced robotics to 3D printing, to create a sustainable and thriving human presence in this new frontier.
Speaking of thriving,
Yeah.
one of the sources mentioned the possibility of asteroid colonies becoming hubs for tourism.
Oh, wow.
Can you imagine taking a vacation to an asteroid resort?
That would be incredible.
Zero-gravity swimming pools,
Yeah.
asteroid hopping excursions,
Right?
maybe even catch a glimpse of a meteor shower from a panoramic viewing dome.
It's a tantalizing prospect,
It is.
and one that is explored in some of your sources.
Yeah.
As space travel becomes more accessible and affordable,
Right?
asteroid tourism could become a significant industry,
Okay.
offering unique experiences and breathtaking views that are simply not possible on Earth.
I can already see the marketing slogans.
What would they be?
Experience the ultimate adventure. Escape the gravity of everyday life. Discover the wonders of the asteroid belt. But in all seriousness, asteroid tourism could contribute to the economic viability of these colonies, providing a steady stream of revenue and creating new jobs in areas like hospitality, transportation, and entertainment.
That's right.
It's like opening up a whole new frontier for human exploration and recreation. It would be a dream come true for space enthusiasts and adventure seekers alike.
Absolutely. And it could also foster a greater appreciation for the fragility and beauty of our planet.
Yeah.
Seeing Earth from afar as a pale blue dot suspended in the vastness of space.
Okay, so we've talked about the potential for mining scientific discoveries and even tourism. It seems like asteroid colonization could be an engine for economic growth,
Yeah.
technological innovation, and even cultural evolution.
It's a really exciting prospect.
But let's get down to brass tacks.
Okay.
What kind of timeline are we talking about here? When could we realistically see permanent settlements on asteroids?
Well, as we mentioned earlier, some experts predict that it could happen within the next century or two, depending on the pace of technological advancement and the level of investment.
Right.
But it's important to note that these are just estimates,
Sure.
and there are many variables that could influence the timeline.
Right. It's like trying to predict the future.
Exactly.
There are so many unknowns, so many potential breakthroughs and setbacks.
For sure.
But are there any key milestones or technological hurdles
Yeah,
we should be watching for in the coming decades?
absolutely. Your sources point to several crucial areas of development
Okay.
that will be essential for making asteroid colonization a reality.
Right.
For instance, advancements in propulsion systems are key.
Right.
We need more efficient and powerful engines to reduce travel times and make it more feasible to transport people and materials to and from the asteroid belt.
So we need a faster, more fuel-efficient way to get around the solar system.
Exactly.
It's like needing a souped-up spaceship to navigate those cosmic highways.
A great way to put it.
And in addition to propulsion, we also need significant advancements in radiation shielding.
Right, that's crucial.
As we discussed earlier, the space environment is incredibly harsh. And we need better ways to protect astronauts and colonists from harmful cosmic rays and solar flares.
Absolutely. We can't exactly slather on sunscreen and call it a day.
So what are some of the more advanced solutions being explored?
Well, one promising approach is using magnetic fields to deflect charged particles,
Okay.
similar to how Earth's magnetic field protects us from solar radiation.
Right.
Another involves developing new materials that are particularly effective at absorbing or blocking radiation, such as composites made with lightweight elements like hydrogen and boron.
So it's like building a cosmic fortress protecting ourselves from the invisible dangers of space.
That's a good analogy.
Yeah.
And it's not just about protecting humans. We also need to develop more robust electronics and materials
Right.
that can withstand the harsh conditions of space.
Okay.
From extreme temperatures to micrometeoroid impacts.
It's amazing to think about the level of innovation and resilience
It really is.
that will be required to build a sustainable human presence in the asteroid belt.
Yeah.
It's like designing a civilization from scratch,
Right.
taking into account every possible challenge and opportunity.
It's a monumental undertaking.
Your sources also highlight the importance of developing closed-loop life support systems
Yes. Absolutely essential.
that can recycle air, water, and waste. We need to create self-sufficient ecosystems within these colonies, minimizing our reliance on resources from Earth,
Right.
right? We can't afford to be wasteful in space.
Absolutely not.
Every drop of water, every breath of air is precious.
Yeah, precious resources.
It's like living in a miniature biodome, constantly monitoring and managing resources to ensure our survival.
Precisely. And as we delve deeper into your sources, we'll encounter even more fascinating concepts and technological advancements that are being explored to make asteroid colonization a reality.
I'm already feeling a bit overwhelmed by the sheer scale of it all.
I can imagine.
It's like trying to wrap my head around the construction of the pyramids
Right.
or the Great Wall of China, but on a cosmic scale.
It's certainly a monumental undertaking, but I think it's that sense of challenge and possibility that makes asteroid colonization so compelling.
Yeah.
It's a testament to the boundless potential of human ingenuity and a reminder that the future is ours to shape.
Well said. But before we get too lost in the grand vision of a multiplanetary civilization,
Okay.
there's one more source I want to touch on.
Right.
It goes into fascinating detail about a specific type of space elevator.
Oh, yes. This paper proposes building a space elevator on Phobos, one of Mars' moons, to transport people and materials to and from Mars with incredible efficiency.
So instead of launching rockets all the time,
Yeah.
we could just take a cosmic elevator ride.
Exactly.
That sounds way more convenient. And probably a lot safer, too.
Precisely. And the paper even delves into the potential of using carbon nanotube cables for this space elevator,
Oh, wow.
a material with an incredibly high strength-to-weight ratio.
Right?
They calculate that with carbon nanotubes. The mass of the elevator would be within a reasonable range.
Carbon nanotubes, those are like the superhero material of the future, right?
They're pretty amazing.
Strong, lightweight, and apparently perfect for building space elevators.
They certainly hold immense promise for a variety of applications,
Yeah.
and the space elevator concept is a testament to their potential in revolutionizing space travel and infrastructure.
It's mind-boggling to think about the scale of these projects. We're talking about building structures that stretch tens of thousands of kilometers,
Yeah.
using materials that push the boundaries of science and engineering.
It's a testament to human ambition and ingenuity. And it's a reminder that even the most audacious dreams can become reality if we dare to push the limits of what's possible.
Well said. But even with space elevators and carbon nanotubes,
Yeah.
there are still some fundamental challenges to overcome
Right.
when it comes to long-duration space travel and living in harsh environments.
Absolutely. And one of the most pressing concerns, as we touched on earlier, is radiation exposure.
Right.
The sources highlight the dangers of cosmic rays and solar flares and the need for effective shielding to protect astronauts and colonists.
Right. We can't exactly slather on SPF 1000 and call it a day.
No, we can't.
So what are some of the more advanced solutions being considered?
Well, in addition to the silicon crystals and magnetic shielding we mentioned earlier,
Right.
there are several other promising approaches.
Okay.
One involves using specialized materials that are particularly good at absorbing or blocking radiation,
Okay.
such as composites made with hydrogen, lithium, or boron. Another involves designing habitats with thicker walls and strategically placed water tanks,
Okay.
which can act as radiation shields.
So it's a combination of material science engineering
Yeah.
and even a bit of clever design to create a safe haven for humans in the harshness of space.
Exactly. We have to get creative.
And these efforts are not just crucial for human health,
Right.
but also for protecting sensitive electronics and equipment. It makes you realize just how vulnerable we are out there in the vastness of space.
Mm.
It's a hostile environment, and we need to be prepared for whatever it throws at us. But it's also an environment brimming with potential and wonder.
Absolutely.
And as we continue to explore and learn, we'll undoubtedly uncover new solutions and possibilities that we can't even imagine today.
That's the exciting part.
For example, one of your sources delves into the intriguing composition of asteroids, specifically those in the Kuiper Belt.
Yes. This source provides a detailed breakdown of the elements and compounds found in these celestial bodies and how they can be utilized for everything from building materials to fuel and life support systems.
So it's like having a cosmic recipe book for asteroid colonization.
That's a great analogy.
What are some of the key ingredients that stand out?
Well, the source highlights the abundance of water ice,
Okay.
which can be used for drinking irrigation
Right.
and even broken down into hydrogen and oxygen for rocket fuel.
Okay.
It also mentions the presence of carbon, nitrogen, and other elements essential for life and for creating various materials.
It's amazing to think that these seemingly barren space rocks actually contain the building blocks of life and civilization.
It is quite remarkable.
It's like nature left us a cosmic care package out there in the asteroid belt.
That's a wonderful way to put it.
And the source even goes into the challenges and potential rewards of extracting these resources, describing specialized mining techniques and processing methods designed for the unique conditions of the Kuiper Belt.
It's a whole new ballgame out there.
So it's not just about finding the ingredients.
Right.
It's about knowing how to use them effectively.
Exactly.
It's like having all the ingredients for a gourmet meal, but needing a skilled chef to turn them into something truly delicious.
You're right on target.
And this source highlights the importance of developing advanced technologies and processes to make the most of these asteroid resources.
Absolutely.
It's incredible to think about the scale of these operations. We're talking about mining and processing trillions of tons of material, creating entire industries and economies based on these asteroid resources.
It's a bold vision for the future.
It's a monumental undertaking.
It is.
But the source suggests that it's within our reach, given the right combination of ingenuity, investment, and collaboration.
I think that's key.
Well, I have to say this deep dive has left me feeling both awestruck by the possibilities and a bit overwhelmed by the sheer scale of it all.
I can understand that.
It's like peering into a future that's both exhilarating and daunting.
I share that sentiment.
Yeah.
But I think it's that mix of wonder and challenge that makes asteroid colonization such a compelling topic. It's a testament to the boundless potential of human ingenuity and a reminder that the future is ours to shape.
Well said. But before we wrap up this epic journey through the asteroid belt, there's one more source I want to touch on. It talks about the potential for colonies in the Kuiper Belt to serve as platforms for groundbreaking astronomical observations.
That's a fascinating aspect.
Yeah, it is.
The source argues that the vast distances between objects in the Kuiper Belt, combined with the extremely cold and stable environment, make it an ideal location for telescopes and other astronomical instruments.
So we're not just talking about mining and manufacturing.
No.
We're talking about pushing the boundaries of scientific discovery.
Exactly.
It's like building a cosmic observatory on the edge of our solar system.
That's a great way to put it.
And the source specifically mentions the potential for using these telescopes to measure the distances to other stars with unprecedented accuracy,
Right.
using a technique called parallax. Didn't we learn about that in high school astronomy?
I think we did.
It's like using the slight shift in a star's position
Yeah.
as Earth orbits the sun to calculate its distance.
That's right.
Yeah.
And the source explains that by placing telescopes billions of kilometers apart in the Kuiper Belt, astronomers could significantly enhance the accuracy of these parallax measurements, allowing us to map the universe in greater detail than ever before.
Wow. It's mind-boggling to think about the scientific breakthroughs could emerge from these Kuiper Belt observatories to uncover new planets, new stars, maybe even new galaxies.
The possibilities are truly endless.
They are.
And it highlights the incredible potential of asteroid colonization, not just for expanding human civilization, but also for expanding our understanding of the cosmos.
It's an inspiring thought, isn't it?
It really is.
That by venturing out into the asteroid belt, we could not only secure our future as a species, but also unlock some of the deepest secrets of the universe.
Indeed, and it's a journey that holds immense promise for generations to come.
It really is remarkable to consider the sheer scope of what we've been discussing. From harnessing the power of the sun with potassium vapor turbines to building space elevators on Martian moons.
It's mind-boggling.
Yeah, it seems like no idea is too ambitious when it comes to asteroid colonization.
It's a testament to human imagination.
But amidst all this technological marvel, have we given enough thought to the human side of this equation?
That's a crucial point, and one that some of your sources do touch upon.
Okay.
We can't just focus on the nuts and bolts of building habitats and mining resources.
Right.
We also need to consider the social, psychological, and even ethical dimensions of establishing a human presence in the asteroid belt.
Right, it's not just about sending robots and machines out there.
Exactly.
We're talking about creating communities, societies, maybe even entirely new cultures adapted to life in space. What kind of impact might that have on human psychology, on our sense of identity, our connection to Earth?
Those are profound questions, and there are no easy answers. Some experts speculate that long-duration space travel and life in isolated asteroid colonies could lead to significant psychological and social changes.
Interesting.
We might see new forms of social organization emerge, new values and beliefs, even new ways of relating to each other and to the universe around us.
It's almost like launching a grand sociological experiment. Observing how humans adapt and evolve in this uncharted territory is both exciting and a bit daunting, wouldn't you say?
It certainly is, and it underscores the need for careful planning and consideration of the human factors involved in asteroid colonization.
Okay.
We need to think about things like crew selection, mental health support, and creating environments that foster a sense of community and well-being.
So it's not just about designing life support systems, it's about designing social support systems as well.
Exactly. We need to create communities that are not only physically sustainable, but also psychologically and socially resilient.
Okay.
Communities where people can thrive, not just survive.
That makes a lot of sense, and it brings to mind another important consideration: governance. If we're talking about establishing permanent settlements on asteroids, who's going to be in charge?
Right.
What kind of laws and regulations will be in place?
That's a complex issue,
Yeah.
and one that will likely involve a combination of international agreements, corporate policies, and community-based governance structures.
It's a bit like the Wild West of space exploration,
It is.
where we're still figuring out the rules of the game.
We are definitely in uncharted territory.
It raises all sorts of questions about property rights, resource allocation,
For sure.
and even the potential for conflict between different groups or nations. We don't want to repeat the mistakes of our past,
Right.
where colonization often led to exploitation and conflict.
I agree. It's crucial that we approach asteroid colonization with a spirit of cooperation and sustainability,
Right.
establishing clear ethical guidelines and legal frameworks
Right.
that ensure equitable access to resources and a peaceful coexistence between different communities.
So it's not just a technological challenge, it's also a philosophical and ethical one.
It is,
We need to figure out what kind of future we want to create in space
right?
and what values we want to guide our actions.
Precisely. Asteroid colonization presents us with a unique opportunity to rethink our relationship with the cosmos,
Yeah.
to create a new chapter in human history that is marked by exploration, innovation, and a deep respect for the interconnectedness of all life.
It's a vision that's both inspiring and humbling.
It is.
It reminds us that we're not just explorers,
Yeah,
we're also stewards of this planet and of our future in space.
well said.
We'll have to say, this deep dive into asteroid colonization has been an incredible journey. Covered so much ground, from the technological marvels to the economic opportunities,
Yeah.
the potential cultural shifts, and the ethical consideration. It's left me feeling both awestruck by the possibilities and humbled by the sheer scale of the challenges ahead.
I share that sentiment. It's a topic that sparks the imagination
Yeah,
and invites us to contemplate the future of humanity in ways we might never have imagined.
it does.
And ultimately, I think that's what makes asteroid colonization so compelling.
Mhm.
It's not just about escaping Earth's problems.
Mhm.
It's about expanding our horizons, pushing the boundaries of human knowledge and ingenuity,
Right.
and striving to create a better future for ourselves and for generations to come.
Well said. And for those of you listening, we hope this deep dive has left you with a sense of wonder and perhaps even a spark of inspiration to learn more about this fascinating topic. We've only scratched the surface, but hopefully we've given you enough to ponder as we continue to venture further into the cosmos.
And if this exploration of asteroid colonization has piqued your curiosity,
Yeah.
we encourage you to delve deeper into the resources that were shared, as there's a wealth of information out there waiting to be discovered.
And of course, if you enjoyed this deep dive, Be sure to like and subscribe to 15-Minute Discourse for more explorations of fascinating topics.
We'll see you next time.
Until next time, keep looking up.